thing's a microphone. Want to sing into it? Okay, so the first thing we'll do is we'll just look at this question from 2003. It's got multiple parts, and I'm positive you can answer part A. I'm positive you could answer part C. Part D, I do want to talk about a little bit here. And one thing that we haven't talked about are labels. Remember, when you're doing rectangular approximation method, you're finding areas of rectangles, and that's going to be length times width. And you can use the labels on your rectangle to come up with the labels of your answer. You just have to pay attention to what those labels are as you do the writing. So, so I've got this problem. It says the rate of fuel consumption in gallons per minute recorded during an airplane flight is given by the twice differentiable function, strictly increasing function r of t. So this is a derivative. It's a rate. It says right here. We've got a rate of fuel consumption. And we're dealing with this over a 90-minute period. Use the data, and let's look at part A first. Use the data in the table to find an approximation for r prime of 45. Show the computations that lead to your answer. Now, I don't have a function to derive. Go ahead.
This is just kind of a reading question. I've always thought of this, but twice differentiable, that just means it can be different.
That means you could, if you had an algebraic function, you could take the derivative and you could take its derivative.
Okay.
And it would be a good derivative. It wouldn't have gaps and stuff. All right. So, tell me how I could approximate r prime of 45. Average what? Average slope. I don't have anything at 45, but that's the problem. I don't give you any information about 45. What do you mean average? Average their slope. You're on the right track.
Like y minus y over x minus x.
Yeah.
40 to 50.
Yes, that's what they're asking you to do here. They're asking you to use a secant line to approximate the slope of a tangent line. So if you took r of 50 minus r of 40 over 50 minus 40, you'd have 55 minus 40 over 50 minus 40, which would give you 15 over 10. Indicate units of measure. Just a minute, Christian. Indicate units of measure. If you look at the numerator, what I'm subtracting would be 55 gallons per minute minus 40 gallons per minute, which leaves me 15 gallons per minute. And on the bottom, I'm subtracting 50 minutes minus 40 minutes, which leaves me 10 minutes. So what is my unit of measure here? Gallons per minute squared. Very good. Now let's go on to the part that we've actually been preparing for in the last couple days. Part C. Approximate the value of the integral from 0 to 90 of r of t using a left Riemann sum, 5 subintervals indicated by the data in the table, which means they want us to use the numbers in the table rather than try to create 5 equal subintervals or 5 equally wide rectangles. So we're going to go integral from 0 to 90. We're simply looking for the area under the curve from 0 to 90, left rectangles. Let's just draw up at each of these points. And now, because I'm using left rectangles, what that means is the left top edge of the rectangle should touch the curve. So here are what those rectangles would look like. So what are the dimensions of the first rectangle? 30 by 20. What are the dimensions of the second rectangle? Say again?
10 by 30.
The third rectangle?
10 by 50. 40, just
10 by 40. The next rectangle?
16 by 20 by 50. 55.
20 by 55. And the fifth rectangle? 20 by 65. So if you go back and you look at the table, how many heights were listed? 6. Which ones did we use? The first 5. And we left off the one that's furthest to the right, and that's going to always happen when you're using a left Riemann sum. If you look at the left column in this table, there's the first rectangle width, 30, then 10, then 10, then 20, then another 20. All right, we need a number. I think we can do this. 600, correct? Plus another 300 takes me to 900. Plus another 400 puts me at 1,300. That's going to be 1,100. Where am I at now? 2,400. And then 60 times 65. That doesn't feel right.
It's 20.
It should be 20 by 65, shouldn't it? So that's another 1,300. Putting me at a grand total of 3,700. All right, so we're at 3,700. Now I need a unit of measure. Pardon me? Now, if gallons didn't jump off the page at you here, and it never would have to me, then let's just stop and let's take a look at what one of these rectangles looks like. So, let's say we look at the first rectangle. The first rectangle had a width of 30. 30 what? It was minutes, wasn't it? It was 30 minutes minus 0 minutes. So the length of that first rectangle is 30 minutes. And what's the height of that first rectangle? 20 gallons per minute. So the area of that first rectangle is 600 gallons per minute times minutes, which just turns out to be 600 gallons. What does that number 3,700 represent?
The number of gallons consumed over.
That's the number of gallons consumed in the first 90 minutes of flight, isn't it? Is that the exact number of gallons? It's an approximate number of gallons. Okay, now let's jump down to part D. We haven't studied what's going to happen here in part D. This is a question that will be covered next week in section 5.3, but you're ready for this. We already know that this number from 0 to 90 is 3,700. So if I took the integral from 0 to 90 of function r of t and divided that by 90, what I would have is 3,700 gallons per 90. 90 what? 90 minutes. This is 0 to 90 minutes. Give me a decimal approximation for 3,700 over 90. 41.111 gallons per minute. What did we just calculate?
The
Average rate. On average, we'd be using about 41.111 gallons per minute to get this done.
I didn't know if you used 90.
I just used the number they gave me, and I related it back to the previous problem.
Okay.
So that I didn't answer their question yet. It says, in terms of fuel consumption, explain the meaning of the integral from 0 to b times 1 over b. Well, if that had been 90, then we would have had the 3,700 gallons over 90 minutes. Had it simply been a smaller number, maybe we integrated from 0 to 30, but then divided by 30, it would still have been some number of gallons per 30 minutes, and then we would have been calculating the average number of gallons used in that number of minutes, 30. Yeah.
So the 41.111, is that also going to work with the mean value theorem, as in someplace on the graph there is 41.1?
Sure is. Sure is. The mean value theorem is going to say, and it's actually a different mean value theorem, because there's two mean value theorems. There's one for derivatives and there's one for integrals. And you've never heard the one for integrals, so I don't know how you're getting that question. But there's a mean value theorem for integrals. Again, that comes in section 5.3, which says the average value has to equal one of the points on the curve. And if you look up here, yeah, it goes through 41.111. All right. Let's keep going. Let's try another one. Turn to 1998, question 3. Now what I have in question 3 here is a picture of a velocity curve. So again, I've got a derivative. And over here on the right, they're just telling me the points that they want us to use from that curve. If this is the velocity, let's consider the acceleration for a minute. You know what? This is a velocity. It's a derivative. Let's sign test it. From 0 to 50, it's always positive. Now let's talk about its acceleration. Acceleration is the slope of velocity.
0 to 35 is
Positive until we get to 35.
negative to 45.
Then negative to 45, and then back to positive. So, look at question A. During what intervals of time is the acceleration of the car positive? Give a reason for your answer. That's not hard. From 0 to 35 and 45 to 50. What's the reason for my answer? Velocity is increasing. The problem with that explanation is you haven't mentioned a word about calculus yet. It has to be something about a derivative or a slope or something along those lines.
The slope of velocity is positive.
The slope of velocity is positive, or the derivative of velocity would be acceleration, and that is positive. Okay, let's skip a couple pieces here and let's drop down to part D. Approximate the integral from 0 to 50 of the velocity with the Riemann sum using midpoints of 5 subintervals of equal length. So if we're stretching from 0 to 50, my 5 subintervals must go 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. And I want midpoints. So how wide is each rectangle? 10, and there's going to be 5 of those. So 10 plus 10 plus 10 plus 10 plus 10. And they want midpoint heights. Well, use the height at 5. Use the height at 15. Use the height at 25. Use your height at 35. And use your height at 45. And you've got it. So I'm going to scroll up. I won't be able to see them anymore. What's the height of the first rectangle? 12. Second rectangle? Next rectangle. Can't hear that. 70. Next rectangle. And finally, okay. Using correct units. Now we've got a number. I don't know what the simplified version of that number is, but we don't have a unit on it yet. So let's talk about the rectangles themselves. That 10 represents 10 seconds, and the 12 is feet per second. You multiply seconds by feet per second, you end up with feet. So when I get done with this calculation, the label on it is going to be feet. Some number of feet. Using correct units, explain the meaning of this integral. You just found the area under a velocity curve. Net change in position, which you would call displacement. But because the velocity is always positive, it never changes direction, displacement and total distance turn out to be the same thing. So you could say it one of three ways. You could say whatever this number is of feet is the displacement of the object, it's the total distance that the object has traveled, or it's the net change in its position. Any one of those is an accurate label.
So the area under the curve is the displacement.
Right. The area under a velocity curve turns out to be displacement. Those of you that are in physics should be familiar with that, right? Area under velocity curve is displacement. Area under a speed curve would give you total distance traveled. If the velocity is always positive or always negative, those two quantities will be the same thing. Hey, look at part C. Find one approximation for the acceleration of the car at time 40. They're asking you for the slope of velocity at time 40. How could you approximate the slope of the car at time 40? Not averaging the slope, but you're on the right track. I don't want the average of the two slopes because I don't actually have those slopes.
Could you just find the slope between, like, the line 35 and 45?
Right. You could, in order to find the slope of the line at 40, I could actually use the line connecting.
What did you have to do?
Wait.
Like the points 35 and its y coordinate and 45 and its y coordinate. It's the only area that it's.
Right. So I could do v of 45 minus v of 40 over, no, of 35 over 45 minus 40. And actually, I'm pretty sure if I looked up the correct answer here, there would be three different correct answers.
Does that be at 35?
Let me try. Let me get rid of that. I'm pretty sure if I went and I looked up the correct answer to this, here's what they would say. You could use the secant line connecting 35 and 45. You could use the secant line connecting 35 and 40, or you could use the secant line connecting 40 and 45. Any one of those three lines could be an approximation for the slope.
But we don't have the slope at 45. So
We don't have enough. We can only approximate it using the secant line. If they wanted it at 45,
Yeah, like there's
then you would use 40 and 50, or 40 and 45, or 45 and 50.
even though it dips down. Like that's the point where it like
Yeah, I mean, I could use a secant line between those two, or the secant line between those two, or the secant. Actually, yeah, the secant line between those last two wouldn't be any good, would it? Because it definitely should end up being a negative number. What are you looking for? I don't have any left on me to use that. Okay, again, if we look at the next problem, what they tell us, and this is the real key when you come around to the AP test, the word you always want to find in these story problems is rate. Because when they tell you you're looking at a rate, they're telling you, I've got a derivative. So this is the rate water flows out of a pipe in gallons per hour. It's given by a differentiable function of r. Table above shows the rates as measured every 3 hours in a 24-hour period. Use midpoint Riemann sum with 4 subintervals of equal length to integrate from 0 to 24. Using correct units, explain the meaning of your answer in terms of the water flow. So if we're going to use 4 subintervals over 24 hours, how long is each subinterval? 6 hours. And I want midpoints, so which of the heights am I going to use in this situation?
3, 9,
I'm going to use the 3, the 9, the 15, and the 21. So the first rectangle is 6 by 10 times 10.4. Second rectangle is 6 times 11.2. Third one is 6 times 11.3. And the fourth one is 6 times 10.2. Again, we need to talk about a label on here. The width is 6 hours, and the height is 10.4 gallons per hour. So when you multiply those things together, you're going to end up with a label of gallons. So we're going to come up with some number. Explain the meaning of your answer in terms of water flow. Not average. You didn't do any division here. The total number of gallons that have flowed out of the pipe. And is it the exact total?
No.
No. So you're going to have some number, I don't know what it is, but it's an approximation for the number of gallons that have flowed out of this pipe in the time interval from 0 to 24, or other words, over a 1-day period. All right, take a look at part B. Is there a place where R prime has to be 0? Is there a place where R prime has to be 0?
yeah.
How come?
Because those are some nice.
First of all, I have no idea what you mean when you say it.
Function.
The function, I don't see a function, I see a list of data.
R of T
R of T
has
So you're writing an explanation now. It is a bad word because nobody knows what it is. And the function is pretty much a bad word too, or bad words, because there's a bunch of functions involved here. There's one specific function they mentioned, but they also said this function is differentiable, so it's got a derivative, and that's going to be a function as well. So when you start talking about the function, nobody knows which function you're talking about except you. So that function has a name. What's that? Right. Call it by its name. The function here, if you're saying the function is R. Now, you've given me good explanations, except all of the explanations I've heard had nothing to do with calculus, because I haven't heard a thing about derivatives or mean value theorems or anything like that.
Maybe like the slope of R of T is from like 0 to 12 and 24. So
Okay, first of all, it's not the slope of R of T, it's R of T,
R of T.
right? And the problem with that is increasing and decreasing are not calculus words. I need something about a derivative.
you say R prime of T is positive
From?
0 to 12, and then it becomes negative, or not it, R prime of T becomes negative 15 to 24.
Problem is, we don't know that it stayed positive throughout this whole interval. We only have selected values. Maybe at time 2, this was actually 8.4. Right? We don't have all that information to say conclusively that it stayed positive. But here's what we do know. I've got a differentiable function. Function R is differentiable, which means function R is also continuous. And if the function is differentiable and continuous, the mean value theorem applies, right? Tell me the slope of the secant line from time 0 to time 24. 0. And because it has a horizontal secant, it must also have horizontal tangent somewhere in between those. And if it's got a horizontal tangent, what's the slope of that horizontal tangent?
0.
0. So somewhere there must be a place where R prime is 0.
You told us to look for that, didn't you? Look for
Yes,
it.
when you have a table of values, hunt in that table for identical y coordinates, because that generally means that they're going to ask you about the mean value theorem somewhere. Oh, it's your first time. It'll come to you. Now, that was a paragraph of explaining I did verbally. Wouldn't be necessary. All you'd have to say is, since function r is differentiable and continuous, and it meets the criteria for the mean value theorem, since the slope somewhere is, since the average rate of change on 0 to 24 is 0, somewhere there must be an instantaneous rate of change. That didn't seem any shorter, did it?
No.
So since R of
Okay,
Z.
stop. Oh, here. Let's try this. I always say, when you start writing your third sentence, you're wrong. So let me pull it up. Let's see what we got. 1999, question 3. Let's look it up. 1999, was that 99 or 98?
99.
99, question 3. There it is. Does it have a place where r prime is 0? Yes. Since r of 0 is 24 and r of 24 is, or since those values are equal to 9.6, the mean value theorem guarantees a place where the derivative is 0.
So you don't need to say that.
You don't even need to say that because it's
No.
Do you not need to say that the mean value theorem applies to?
You did. You said it right here, the mean value theorem.
But how do you?
By mentioning it, you're saying it. Okay. So that's all they need. Look at how concise that is. And if you look at, now I'm a reader, so my criteria is I have to look for two things. The word yes and the 3 letters MVT, or the words mean value theorem.
That's all you're looking for.
Then all I have to do is examine it to make sure you didn't write down anything that's blatantly not true, such as r prime is always positive on a given interval, which might not be true. Yes?
you know your grades, like the line you have to the letter. There you go.
So, writing explanations is kind of a luxury, to tell you the truth. I added them all up one year, and there was 6 explanation points on a test. We spend way more time talking about explanations than they warrant. 6 points, and think of all the time we'll talk about how do you write these explanations. But of course, writing the explanation is a skill that goes way beyond calculus. So we're not going to tone that down. I'm going to continue to give it way more time than it warrants on the AP test, because that's one of the truly valuable skills you get out of this class that hopefully you can apply in other places. All right, that's about enough of that. You're not ready for part C in that question. Okay, I think you've heard about enough from me for today, so I'm just going to stop right there.